morning to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. So in this video, we are going to discuss about the disjoint set and what are the operations on disjoint set. So what is the definition of set? Set is a unordered collection of items that are enclosed in flower braces. 1, 3, 5, 7 are called as elements of the set. All the elements of the sets are enclosed in a flower braces. Then it is called as a set. Now coming to the what is meant by disjoint set. Consider the two sets Si and Sj. I not equal to j. That means these two are different sets. S1 is the first set. S2 is the second set. I is nothing but 1. J is nothing but 2. That means there are two different sets. The two set does not contain the common element in both sets. Then the two sets are said to be a disjoint set. For example, S1 consisting of 4 elements 1, 7, 8, 9. S2 consisting of 2, 5, 10. So S1, S2 are the two sets. But if you consider the two sets, there is no common element in two sets, then S1 and S2 are said to be a disjoint set. I not equal to J means they are not belongs to the same set, they are coming to the different set. If the element is not present in both sets, the common element is not present in the both sets, then the two sets are said to be a disjoint set. S1, S2 are disjoint, S2, S3 is disjoint, S1, S3 are disjoint. So these disjoint sets are represented by using tree representation. So the first node is called as a root node. In the list of elements, the first element is called as a root node. Whatever the leftover elements in the set, that is 7, 8, 9 are called as children of the set. That means 7 is connected to 1, 8 is connected to 1, 9 is connected to 1. That means 7, 8, 9 are the children and the parent is 1. Parent is 1, 7, 8, 9 are the children of the set. Consider the same set says to 2, 5, 10. Here we can take any one as a parent, 5. Remaining two elements are children of the set. That means 2 parent is 5. That is denoted by using the arrow mark in the upward direction. 2 parent is 5. Same way 10 parent is 5. That is second set. In this third set, again 3 is considered as a parent. Remaining two elements are called as children of the set. That is 4, 6. These two are the children of the set 3. So 3 is a parent. The topmost node in the tree structure is called as a root node, or it is a parent for the remaining two children. So disjoint set means the two sets does not contain the common element, then the two sets are said to be a disjoint set. These disjoint sets are represented by using the tree representation. This is the representation of the sets. Now we are going to perform the two operations on set. First one is called as a union, second one is the find. These two are called as a disjoint set operations. First one is a union, second one is a find operation. First, what is the meaning of union? The first operation is union. Union means we need to combine the two disjoint set element as a single set. So for example, S1 union S2. Then what are the elements? For example, S1 consisting of 1, 2, 3. Whereas S2 consisting of 4, 5, 6. The two elements are combined, then we are going to get a single set as 1, 2, 3, 4, 5, 6 and all elements are consisting of a single parent. That is the disjoint set union. So previously we considered the two sets. S1 is 1, 7, 8, 9. S2 is 5 to 10. When you are performing a union operation, S1 and S2 will be considered as a single set and all the elements consisting of only one parent. So S1 and S2 will be represented by using the tree structure. For example, this is a 1, 7, 8, 9. Again, this is the second set. This is the second set tree representation. Again, 5 is another set. Make it as a 5 parent as 1. Then this is called as S1 union S2. Or S2 union S1 means this is the S2 and union S1 means this second set is added to the first set and make one of the element as a parent. So previously, in the case of before performing the union operation, these two sets are different sets and these two are represented by using the two different tree structure. When you are going to perform the union operation, these two sets are combined together as a single set and we have to represent it by using a single tree structure. Make any one of the node as a parent and remaining all are considered as a children. So in this example, for this 2, 10 parent is 5, again 5 parent is 1. Again 7, 5, 7, 8, 9 parent is 1. This is the disjoint set union operation. Next one is a find operation. In the case of find operation returns the root node. Root node or parent node. So where the particular element is present, that is called as a find operation. Find of 4, that means where 4 is present. 4 is present in a set 3, that is the find operation. Find operation returns the what is the node, where that node is present, in which set the node is present, that is returned by the find operation. Next, find of 1. So where 1 is present, 1 is present in set 1, that is S1. Find of 10 means where the 10 is present in the set 2. S2. Okay. So that is the representation of find operation. We are going to perform two operations in the find as well as union. Find operation returns the root node or parent node, or directly it returns in which node, in which set the particular node is present. That is returned by the find operation. Whereas union operation combines the two trees or two sets as a single structure or single tree structure. Next, the data, how the data will be represented in the case of set. One format is like a linked list structure. It is a linked list structure. It consisting of two fields, that is what is the name of the set. Second one is which node it is pointing. S1 is pointing. This is pointing to S1 set number 1. So this is the set number 2. How we are connecting the set name with the corresponding tree structure by using a pointer field. Pointer field gives the where the particular tree structure is present. Whereas S3 is present in this tree structure. So this is called as a pointer that gives the location where the particular set is present. So in the case of find operation, we are going to return what is the corresponding parent. So for the root node, parent is -1. For the root node, parent is -1. For the remaining nodes, it returns the corresponding parent. So this is the important point. So in the case of parent means for the root node, the parent is -1. For the remaining nodes, it returns as a corresponding node, parent node, or it is a root node. Let us consider the previous example, that is a S1, S2, S3, that means three sets. S1 is 1, 7, 8, 9, 2, 5, 10. So here 7, 8, 9 parent is 1. Remember 7, 8, 9 parent is 1. 2, 10 parent is 5. 4, 6 parent is 3. For this 1, 5, 3 value is -1 because they are root nodes. For root number 1, root node 5, root node 3, parent value is -1. For the remaining nodes like 7, 8, 9 parent is 1. 2, 10 parent is 5. 4, 6 parent is 3. Let us look at the example. So I is nothing but a corresponding nodes. That means there are 10 nodes are there, that is numbered as 1 to 10. Next, so 7, 8, 9 parent is 1. 7, 8, 9 parent is 1. Next, 7, 8, 9 is connected to 1. So 1 is a root node, parent value is -1. Next, second structure, that is a 2, 5, 10. 5, 2, 10. 5 is a root node. 2, 10 is connected to 5. 2, 10 parent is 5. For 2 and 10 parent is 5. For 5 it is a root node. Parent is -1. Parent is -1. Third tree structure 3, 4, 6. 3 is a root node. 3, 4, 6. 4, 6 parent is 3. 4, 6 parent is 3. 3 parent is minus 1. So, like that we are going to store the corresponding nodes and the parent nodes in the form of array structure. Now, coming to the algorithm for union as well as find. How to join the two trees. Okay. Consider the first tree as 1, 2, 3. Second one is 4, 5, 6. This is S1. This is S2. So, algorithm for finding union of I, j. I means 1, first set. J means second set. J means second set. We are going to perform the simple union operation. Simple union of I, j. 1, 2. Then, parent of 1 is 2. That means second node or second set parent is 1. That means we are going to join. So, actually before that there is a 1, 2, 3 is there. Next, second node parent. Second node is, this is the second node. The second node parent is 1. Like that we are going to join. That is the parent. So, that means we are going to combine the, before that there are two different trees, 1 and 2. Then parent of, that means second set parent becomes the first node parent. Okay. That means second node is added, second tree is added to the first tree. Then it is called as a union operation. Now, coming to the find of I. I need to find out what is find of 4. Who is the parent of 4? Who is the parent of 4? Next, simple find of 4. I value is 4. Next, while loop is repeated until condition becomes false. While P of 4. What is parent of 4? Parent of 4 is 3. 3 greater than or equal to 0. Condition true. Condition true, then I equal to P of 3. That is P, I value equal to 3. Next, again P of 3 greater than or equal to 0. What is P of 3? Means parent of 3. Parent of 3 is minus 1. Minus 1 greater than or equal to 0. Condition false. Return I. What I consisting of 3? That means find of 4 returns 3. Find of 4 returns 3. That is find operation returns the root node or it is a parent node. But there is some problems are there in the case of simple find as well as union operation. You consider the simple union operation for each operation, for each step it takes a big O of 1. So, for if you perform n minus 1 unions, it takes a big O of n minus big O of 1. It takes the time complexity as big O of n is the time complexity for the simple union operation. For one operation, one union operation, 1 is the time complexity. If you perform n number of operation, it takes the time complexity as a big O of n. If you consider the find operation, suppose it is a level I. It is a level I. The time complexity is big O of I. If it is a number of levels are increased, the time complexity is increases. But to get the best performance of algorithm, the time complexity should be less and space complexity should be less. Then it is a best algorithm. We need to measure the performance of algorithm by considering the two metrics like a time complexity as well as space complexity. The algorithm which takes the less time, that is the best algorithm. But if you increase the number of levels in the case of operations, that is a disjoint operation, the time complexity will be increased. So, that is the big O of n square is the time complexity. To overcome these problems, we are going to find out another two operations in disjoint set called weighting rule and collapsing rule. So, there are two rules we are going to discuss now. Okay. First one is a weighting rule. Another one is a collapsing rule. To overcome the problems in simple union, and simple find, the two algorithms has been developed. One is a collapsing rule. Another one is a weighting rule. In the case of weighting rule, if the number of nodes in the tree with root I, that is root I, 1. Next, second one, 2. If the number of nodes, how many nodes are there in the first tree? Only one node. How many nodes are there in the second tree? 3 nodes. If the number of nodes in the tree with root I less than the number of nodes in the root j, so that is 1 is less than 3, then make j is the parent of I. This is the parent of I, means one parent is 2. Otherwise, suppose first tree contains more number of nodes compared to the second tree, then make j is the parent of I. This is the rule we are going to follow. Let us discuss with the help of example how the weighting rule will work to perform the union operation. Consider initially there are n number of nodes. All are at the root level or it is a topmost level. Union of 1, 2. That means 1, 2 means 2 will be added to the 1 and 2 parent is 1. That is union of 1, 2. Union of 1, 3. Already union of 1, 2 is there. We need to join 3. 3 will be added and 3 parent is 1. 3 parent is 1. Next, union of 1, 4. Already 1, 2, 3 is there. Add 4 as the node and make 4 parent is 1. 4 parent is 1. Like that we need to perform n number of union operation. Proper performing all union operation will get the tree structure like that. What is the basic rule we are going to follow for weighting rule is we need to compare the number of nodes in the first tree as well as second tree. If the number of nodes in the first tree is less than the number of nodes in the second tree, make I as the parent of j, or otherwise we need to make j as the parent of I, depends upon the number of nodes. That is the weighting rule. So consider this example. We need to perform the weighted union. Consider the two sets I and j. I not equal to 6. That means these two are different sets. 1, 2 as two different sets. So P of I, we need to perform. This is one tree structure. 1, 2, 3. This is the first node. Again 4, 5, 6. This is the second tree. How to perform the union operation? Okay, how to perform the union operation? Need to remove this node. Only 2 nodes. We need 2 nodes. Okay. So P of I, this is the first node. This is first tree. This is the second tree. So P of I means count of I. That means total number of nodes in the first tree. That is 3. Next, P of J means second node count. That is 2 nodes are present. Temp equal to P of I plus P of J. That means total number of nodes that is stored in the variable called temp. Next, if P of I means P of I is 3 greater than 2, 3 greater than 2, condition true. First node having more number of nodes compared to the second node. Then I has fewer nodes. P of I means 3, 3 greater than 2. I has a fewer nodes. Then P of I is greater than J. So that is 3 greater than 2, condition true. P of I, that means parent of 3 is 2. 2 parent is, that means second node parent is 1. Second node parent is 1. So what is the second node parent? I is nothing but a number of nodes. The second node parent is node. Again P of J equal to temp. So that means what you are going to do is 1, 2, 3. J. J means 4. 4, 5. This is 4, 5. Then J, that means second node, parent is 1. And P of J, that means total value. J is nothing but a total count. The total count is temp, that is total number of nodes equal to temp. What the temp consisting of? Temp consisting of 5. Suppose J has a fewer nodes. That means P of J, parent of J. So same thing we are going to, when we add number of nodes, the total count is incremental. So when we are going to add, if the number of nodes in I less than the number of nodes, I less than J, follow this condition. If it is a J has a fewer nodes, follow this condition. I has a more number of nodes, j has a fewer nodes, we need to follow the second condition. P of j, parent of j is 1, then total values will be stored in the total count value. So I greater than j, condition true, then we are going to follow the first condition, otherwise we'll go for the second condition. Depends upon the number of nodes. So second one is a collapsing rule. So in the case of collapsing rule, we need to consider the weighted union. That means 3 will be added. Total number of nodes are 1, 2, 3, 4, 5, 6, 7, minus 8. Temp contains minus 8. What is the parent of one parent is minus 8. Total number of nodes. Again, 2 parent is 1, 3 parent is 1, 4 parent is 3, 5 parent is 1, 6 parent is 5, 7 parent is 5, 8 parent is 7. So like that we are going to allocate. What is the use of collapsing rule? It can collapse all the nodes and it returns the root node. Suppose I want to find what is find of 8. So remove, it will be collapse all the nodes that are present in this path and find or returns the root node of the corresponding parent. Let us look at the example or algorithm how the collapsing rule will work. So find the root node of the tree containing element I. Use the collapsing rule to collapse all the root from I to root. Or suppose I want to find of 3. Here I equal to 3. Then coming to the R equal to I means I value is assigned to R equal to 3. Next, while P of R means parent of 3 greater than 0. What is parent of 3 is 1. 1 greater than 0. Condition true. Then R equal to, condition true, then R equal to P of 3. That means P of 3 means R value is 1. While I is not equal to R. I value is 3. R value is 1. 3 not equal to 1. Condition true. Next, S equal to P of 3. What is S value? P of 3 means parent of 3 is S equal to 1. P of I means P of 3 equal to R. R value is 1. Next, I equal to S. I value is what? S. That means I value is 1. Next, while loop is repeated until condition becomes false. This is the first iteration. Coming to the second iteration, while I value becomes 1, 1 not equal to, what is R value? R value is 1. 1 not equal to 1, condition false. It returns R. What is R? R is 1. R is 1 is returned. What is R equal to 1 means parent of 3 is 1 is returned by the collapsing rule. So in the case of collapsing rule, it will be collapse all the nodes in between the root node to corresponding path and returns the corresponding parent node. So what we have discussed up to now, what is meant by set? So what is meant by disjoint set? What are the operations on disjoint set? That is a first rule is simple union. 4 operations, simple union. Second one is a simple find. Third one is a weighted union and collapsing rule. These are the 4 operations that we are already discussed in the case of disjoint set. What is the definition of set? What is the meaning of disjoint set? How to represent the disjoint set? What are the operations on set? Union means it can combine the 2 sets as a single set. Find means it returns the corresponding root node or parent node. Weighted union means why we are already simple union, simple find is there. Why should we follow the weighted union and collapsing rule means simple union, simple find can increase the time complexity of algorithm. To overcome that problem, we are going to find out the weighted union and collapsing rule. So the purpose is same. Weighted union also combine the 2 sets, but they are going to follow some rules before adding the 2 trees as a single tree. Collapsing rule always returns the root node or it is the parent node. As the name implies, it will be collapse all the nodes in the path from root node to the corresponding node and returns the corresponding parent. Thank you.